Hi, in this video today I want to explain how to solve population genetics problem using Hardy-Weinberg formula. And today's problem is, for the cystic fibrosis gene, the allelic frequency of the normal allele is 0.975 and of the mutant allele is 0.025. And here is the 4 questions that we have to answer today. And in order to answer these questions, I'm going to use Hardy-Weinberg formula in order to find allelic frequencies. And here is a formula. So frequency of the alleles in the population would equal to p squared plus 2pq plus q squared, and all this would equal to 1, and p plus q equal to 1, and 1 equal to 100%. And we told that frequency of the dominant allele, that is p here and here, so the total number of p of the dominant allele is frequency is 0.975. So p equal to 0.975, and q would equal to 0.025. So now it would be very easy to find p squared. We just have to multiply p by itself, so p squared would be 0.975 squared, and the answer here would be 0.9502625, and q squared, that is here, would be once again frequency, that is 0.025 squared. So if we multiply this number by itself, we are going to get 0.000625. So this is going to be q squared. So now we can solve the whole formula, because we know p and q here, so we can find frequency of the heterozygous in this gene pool. So the frequency of the heterozygous would be 2pq. So this is going to be 2 multiplied by number p, that is 0.975, and multiplied by 0.025. This is number q. So we just have to multiply p, that is here, by q, that is here, and multiply by 2. So this is what we have here. And the answer here would be that frequency of the heterozygous would be 0.04875. So this would be frequency of the heterozygous. So let's now read the questions. So what is the probability that the person would be phenotypically normal? And as you see, these two genotypes represent normal phenotype. So this heterozygous condition here also would be normal phenotype, because cystic fibrosis is a recessive disorder. So only those people who have two recessive alleles, that is Q squared in this formula, would express this disease. And those who is heterozygous or homozygous dominant wouldn't express this disease and would be phenotypically normal. So we have to add this number p squared, this number to this number 2pq that is here, and here is a number. So let's do it. So phenotypically normal people would be p squared plus 2pq, and this is going to be 0.95, 0.625 plus 0.04875, and the answer here would be 0.999375. So this would be how many phenotypically normal people would be in this population. So as you see, this is going to be 99.94 if we round the answer percent, so almost 100, but not exactly. And we can give the answer as percentage, so we just have to multiply by 100. As you see, 1 would equal to 100%, so we just have to multiply by 100 or move this comma 2 decimal places to the right. So the answer would be 99.9375%. So this would be frequency or percent of the phenotypically normal people in this population. And the second question will be carrier, and as you see here, this stands for the carrier, and here is the number. Once again, we can give the answer as percentage. We just have to move this comma 2 decimal places to the right, and the answer would be 4.875%. This is going to be percent of the carriers. And we'll have cystic fibrosis, and this part of the formula stands for the frequency of the those who has this disease expressed. So this is going to be percentage in the population, and this is going to be, if we move this comma 2 decimal places to the right, would be 0.6. So this is going to be 0.06 and 25. So less than 0.5%. And the last question, what percent of the phenotypically normal people will be carriers? And in order to solve this problem, we just have to add this number to this number. This is going to be 100% of the phenotypically normal people, and we already have this number here, that is here. And now we have to divide this number of the heterozygous by this number. So we have this number heterozygous here. So we have to divide 0.04875 by total number of the people who looks phenotypically normal. So this is p squared, homozygous dominant and heterozygous, So we have to put here this number. So this is going to be 0.9999375, and the answer would be 0.0444903. Once again, we can move this comma 2 decimal places to the right, 2 places, and the answer would be so the answer would be 4.49%. I would you can of course round this number to 4.5% or to 2 decimal places. This is going to be 4.49%, or you can use the whole number. So this is going to be 0.3, and this is going to be a percentage of the people who is going to be heterozygous out of course those people who is going to be look phenotypically normal. So we answered all the questions. So I don't have much space here, so I put 4.49% here as an answer. So this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Goodbye.